Here is a quiz review video about finding an indefinite integral and using the power rule to find the antiderivative. So I'm going to do page 17 and 18 for number 5. We start with a constant, number 5. We start with a constant, so that changes to 1/2 x plus c. And I'm using x since they tell me dx, that's the variable x to use. For 6, the coefficient carries to my answer. I add 1 to my exponent, divide by the new exponent, plus c. For 7, I can't do the antiderivative yet until I move the variable out of the denominator by making the exponent negative. So now I can add 1 to the exponent and divide by the exponent. But this doesn't look very nice. We don't write a negative coefficient in the denominator. So I move the negative coefficient to the numerator. This negative exponent allows me to move the variable to the denominator, plus c. For 8, I have to change the radical to an exponent. Then I'm going to do the power rule where I add 1 to the exponent divided by the new exponent. But we don't leave the answer with divided by a fraction, so we multiply by the reciprocal to get the final answer. So 3/2 plus 1 is 5/2 divided by that new power, multiplied by the reciprocal of the denominator to get my final answer. So then for 10, now we have a binomial, so I can individually do the antiderivative of x and then of 4, and don't forget your plus c at the end. Same thing for 11. The coefficient carries to my answer, and then add 1 to the exponent divided by the exponent, minus, and continue the power rule for every term. But then I have to look and see if any of my coefficients can simplify. So 4 divided by 4 is 1. Nothing can simplify here. And that's the final answer for 11. All on the back. Now we have a product and a power. So for 12, I can't just do the power rule. So instead, let me rewrite my problem. I have to do some u substitution to be able to take the antiderivative. I'm going to make the inside term my u. So 3x to the 4th plus 1. I chose that because when I take the derivative of x to the 4th, I get x to the 3rd. So I'm going to replace u in the equation, rewrite everything I have left. I'm going to find the derivative of u. And then I'm trying to replace x cubed dx. So I'm going to multiply the dx to the right. Go like this, dx, dx. And then I only want x cubed dx. So I'm going to divide both sides by 12 and rewrite this as 1/12 du. So now I can replace the x cubed dx with what is equal, 1/12 du. My variables now match, everything's u's, so I can do the power rule. And then to finish, I'm going to multiply my denominators, substitute back in what u was, 3x to the 4th plus 1, and don't forget your plus c at the very end. So I'm going to do the same thing for 13. I'm gonna pick my u to be x cubed plus 6x, because when I take the derivative, I'm going to get that part of my integrand. So that's the integral of u squared. The remaining pieces, do my derivative. I see that this matches exactly, so I'm going to multiply the dx to the right. So I can replace all of this with du. Do the power rule and replace my original u function. All right, 2 more. 14. So I'm going to make the inside my u. That's really the only choice. But I'm going to run into a problem. So when I go to take my derivative, I get 12x to the third. Well, I only have 2 dx here, so let me see what happens when I isolate the dx. So I multiply dx to the right. I'm going to divide by 12x cubed. So du over 12x cubed is dx. So we get u squared 2 du over 12x cubed. So here's my problem. I still have a mix of variables, a u and an x cubed. There's no way to replace the x cubed so that I have all u variables, so this will not work. Let's try again. Instead, since the power on the problem's only squared, I can multiply the binomials together to make the polynomial in standard form so that then I can do the power rule. So 3x to the 4th times 3x to the 4th is 9x to the 8th. Oops. Then 3x to the 4th times 1 plus 3x to the 4th times 1 plus 1 times 1. I'm going to combine my like terms. These can be added together. Distribute the 2. And now I can do the power rule because it's just a polynomial like the beginning numbers 10 and 11. So bring down the coefficient, add 1 to the exponent divided by the exponent for every term. Don't forget plus c at the end. And then 18 divided by 9 simplifies. 12 divided by 5 does not. And that is the final answer for 14. And last but not least, 15. So the derivative of x squared is x, so that's going to be my u. When I rewrite u in my integrand, I'm going to change the square root to a 1/2 power. At a minimum, we have to replace x dx. Extra numbers are okay, extra x's are not. I'm going to multiply dx to the right. So here's that x dx, so I'm going to divide the 2, so I get 1/2 du is x dx. So I'm going to replace that over here. Five times 1/2 is the coefficient that's going to carry to my answer. Add 1 to the exponent divided by the new exponent. Instead of dividing by a fraction, we're going to multiply by the reciprocal. 5/2 times 2/3, well, these 2's divide to 1, so we get 5/3. I'm going to fill in the u function, which is x squared plus 1. And that is our final answer. And now you are done your quiz review. Make sure you can do all of these problems independently for the quiz, since quiz is independent work to show me what you know.